Hello, this is Cinderella Math, and today we'll be looking at the Kuta Software worksheet on dividing polynomials. This is for pre-calculus, could also maybe be like an advanced algebra 2. And yeah, we're just going to work this out straight down, starting with 1 through 4. The directions want us to see if that smaller linear function d of x is a factor of the larger polynomial function f of x. So we want to divide these. I'm going to do synthetic on these. And the name of the game here is it is a factor if the remainder is 0. So doing synthetic here on number 1, and the reason we can do synthetic is because this has a coefficient of 1 and a power of 1. If that was not the case, we wouldn't be able to do synthetic, but we can here. You're going to take it, set it to 0, the smaller one, and that's going to be x is -2. Take that number, and we're going to set that to the side. I sometimes call that the little timeout box because he's set to the side there. And then take your coefficients of your larger function and then just write them in a row. Give yourself some space and then draw a line and drop the first number straight down and multiply by the timeout box. So 3 times -2 is -6. Write that in the next available column and then add straight down. 7 plus -6 is 1. Multiply, next available column, add straight down. Multiply, add, multiply, add, and we have a remainder of 2. So this is not a factor. Since the remainder is not 0, it is not a factor. And let's do that again. Coming over to number 2, we can do synthetic because this is a 1 and this is a 1. So we're in business for synthetic. We're going to set to 0. So x is -1. That number will go in the box. And then make a string of your coefficients. Don't forget about those pesky -1s that are hiding right there. Skip a space, draw a line. Okay, drop down, multiply by the timeout. Add straight down. Multiply, add, multiply, add. This is our remainder. This is going to be a no as well. This is not a factor because that remainder is not 0. And we're going to do this twice more, dropping on down to number 3. We're going to set to 0. Again, you can do synthetic because this is a 1 and this is a 1. Solving that, x would be 1, so that's our timeout number or the box number. And then let's take our coefficients. Don't forget that invisible 1. Skip a line, draw a line, drop down. Multiply by the timeout. Add straight down. Multiply, add, multiply, add, and our remainder is 0. This is good. We do have a factor. So x minus 1 would be a factor of that big polynomial function. And finally, number 4, we can do synthetic because this is a 1, this is a 1, so we're good. We're going to set this little guy to 0, which will give us x is 2. So 2 goes in our box. Make a string of your coefficients. Skip a line, draw a line. Drop your first one down and multiply, add, multiply, add, multiply, add, multiply, add. And I think we're looking at a no because that is not a 0. Yep, that one is also no, not a factor. So the only one that was number 3 because that's the only one that resulted in a remainder of 0. The next section just says divide and wants our answer in fraction form. So let's see here. Okay, the first two we can do synthetic because on the divisor, the little guy, this is a 1, this is a 1. So we're going to set this little guy to 0, and that would be -2 into the box, and now make a string of coefficients from the big guy, the dividend. So we have 2. Careful, there are 0 x4s, right? X to the 4th. We don't see that, but we do need to put that 0 in, otherwise the synthetic won't work out right. And now we're good. So just watch out for those invisible zeros. You won't always have that. Just be careful when something's missing. See how it went from 5 to 3? We need it to be like stair steps. 5, 4, 3. So that's why we put in that invisible 0. And now we're ready. We're going to drop down, multiply by the timeout, add straight down. Multiply, add, multiply, add, multiply, add, multiply, add. Okay, now this is your remainder. So kind of just set him to the side for a second. And we're going to work our way backward. So this is going to be a constant. Give him an x, give him an x squared, x cubed, x4. So again, it's kind of stair step. Just always remember that the first one past the remainder is a constant, so he doesn't get an x. And technically it's x0, right? So we don't need to write that though. All right, so our final result here on number 5 is 2x to the 4th minus 4x cubed minus 7x squared plus 5x plus 1, and now this pesky remainder, see this fraction form? That means we can't just put remainder 10. We're going to say plus, because that's a positive 10, over the divisor. That's what was left over. And that would be your final result. So you always take your quotient plus the remainder over the divisor. If your remainder is 0, then you don't have to worry about it. But we did have a 10 this time. If the remainder would be negative, this plus would change to minus. I'm sure we'll probably get one like that. Okay, let's do that again on number 6. We can do synthetic because this is a 1, this is a 1. So let's do synthetic. Take that divisor, set to 0. So x is 5. That's our timeout number, or the box number. And then let's take our string of coefficients. Watch out for the 1s and the negative 1s. We don't have any zeros on this one because it just stair-stepped down. 4, 3, 2, 1, constant. So no invisible zeros this time. Skip a line, draw a line, and now we're ready. We're going to drop down, multiply by the box, add, multiply by the box, add, multiply, add, multiply, add. This last guy is our remainder. This go backwards, so right to left, constant, give him an x, give him an x squared, give him an x cubed. So our final result is x cubed plus 4x squared plus x plus 2, and now our remainder is minus 9 over the divisor. That would be our final result for number 6 using synthetic division. Now 7 and 8 on this page here, we cannot do synthetic. So we will go long division. Looking at 7, why can't we do synthetic, by the way? This is a 1, but this is not. So synthetic will not work out here. So we'll just do long division, divisor on the outside, big function, big dividend in the box, or in your house, if you will. And you want to ask yourself, 2x times what would be 10x to the 4th? And we may even want to come off to the side and write that. You may not need to, but feel free if you do. 2x times what would be 10x to the fourth? Well, 2 times 5 would give us 10. This has 1x and we need 4. So if we give him 3 more. So we're going to multiply by 5x cubed. That will give us 10x fourth, and we'll multiply here too to be negative 10x cubed. And then with long division, we take this whole guy and we subtract him. So subtract straight down. The first component should cancel. 10x to the fourth minus 10x to the fourth. This should cancel out. And the second one, be very careful. That's negative 4x cubed minus negative 10x cubed. This will turn to plus and be 6x cubed and drop down the next component. And now we're going to repeat that process. We want 2x to look like the new first component. So 2x times what is 6x cubed? Again, you may not need to do this to the side. If you can do it in your head, by all means. 2 times what is 6? So that would be 3. And then he has 1x, but he needs 3, so we're going to give him 2 more. So we're going to times by positive 3x squared. And let's do that. That would be 6x cubed. Multiply this guy as well. Negative 6x squared, and we're going to subtract that entire result. The first component should cancel out. It does. And be very careful. This is 14x squared minus negative 6x squared. So that would turn to plus and be 20x squared. Drop down. And then we repeat again. We want 2x to be the new first component. So 2x times what is 20x squared? We need a 10 and one more x. So a positive 10x. And we're going to multiply that through. That would be 20x squared. And negative 20x, subtract straight down. The first guy cancels. Careful, this is negative 14x minus negative 20x, turns to plus, and we get 6x. Drop down. I'm going to run out of room. I'm sorry. Almost there. We got this. Last one here. We're going to say 2x needs to look like 6x. So 2x times what is 6x? Just need a 3. Positive 3. Multiply. That would be 6x. Multiply. That would be negative 6. Subtract. Let me come up here for room. So we have 6x minus 16. Subtract 6x minus 6. The first component cancels. Careful, we have negative 16 minus negative 6, which will turn to plus and be negative 10 as our remainder. All right. So up on top is our quotient. And then we just have to mess with the remainder as well. Oh, sorry, that's horrible. So final answer on 7, we have a quotient of 5x cubed plus 3x squared plus 10x plus 3, and then our remainder is negative 10 over the original divisor. That's going to be your final answer for 7. And we have one more on this page. Number 8, we cannot do synthetic because of this 3. So we're gonna go ahead for long. I'm gonna just go ahead and get a whole lot of space here. Okay, so you're gonna ask yourself 3x, we need it to turn into this. So what do we need to multiply by? 3 times 3 would give us 9. He has 1x and he needs 5, so he needs 4 more. Let's do that. That would be 9x to the 5th, and he gets to go as well. negative 15x to the fourth. Subtract. The first cancels, and careful, that's negative 9 minus negative 15, which would turn to plus and be 6x to the fourth, and drop down. If you want to put the invisible 1, feel free. And then let's go again. Okay, so we ask ourselves, 3x needs to look like the new first component. 3 times 2 would be 6, and he needs 3 more x's to be x to the fourth. Let's do that. That would be 6x to the fourth. This guy gets to come to be negative 10x cubed. Subtract. First guy cancels out. Careful, this is negative 1 minus negative 10. Turns to plus, and we get 9x cubed, and we drop down. Go again. We need 3x to be the new first component. 3 times 3 would get us 9, and then he needs 2 more x's to get up to x cubed. That would be 9x cubed. And that would be negative 15x squared. Subtracting. Straight down. First thing cancels, and we have negative 12 minus negative 15. Turns to plus, and we get 3x squared. Drop down. Put the 1 if you need it. Almost done. 3x to 3x squared. He's just missing an x, because that would give him 3x squared minus 5x. Subtract straight down. The first one's gone, and we are doing 1 minus negative 5 turns to plus. We get 6x, and we're going to drop that constant. I'm going to come up here for room. We're at 6x minus 11. All right, almost there. 3x needs to look like 6x. So if we just do a 2, that would be 6x, and that would be negative 10. Subtract. Bye-bye. Negative 11 minus negative 10 turns to plus, and we get a remainder of negative 1. Woo! That's long. All right, final answer here. This was number 8. We had a quotient of 3x to the fourth plus 2x cubed plus 3x squared plus x plus 2 with a remainder of minus 1 over the original divisor, which was 3x minus 5. That is number 8. Woo. And I think the whole back side is, oh, well, one of them actually we can do synthetic. Okay, let's flip over to the next side here. Looking at number 9, we need to do long again because the first number in the divisor is not 1. Right here, this is our culprit. Okay. This is number 9. Okay. 4x needs to look like this guy. 4 times 4 is 16, and he needs 3 more x's to be 16x4 minus 4x cubed. Subtract straight down. First thing cancels. 4 minus negative 4. Come off to the side if you need to. That would turn to plus and be 8x cubed. Drop down. And then let's go again. Sorry. Okay. Now we need 4x to look like 8x cubed. 4 times 2 is 8, and he needs 2 more x's so he can match. That would be 8x cubed minus 2x squared. Subtract. This guy's gone. That's 2 minus negative 2 turns to plus, and we get 4x squared, and we drop down. All right, 4x needs to look like 4x squared, so he's just missing an x. To get him to be 4x squared minus 1x, subtract, cancel, and that's negative 21x minus negative 1x, so that adds to be negative 20x, and we drop down. I'm going to come over here for room, so we're at negative 20x plus 7. All right, and now 4x to be negative 20x, we need negative 5. That would be negative 20x, and that would be positive 5. Watch your signs there. Subtract, minus minus, this would turn to plus and then cancel. 7 subtract 5 would be 2. There's our remainder. Okay, so our final answer on 9, this is our quotient up here at the top. So 4x cubed plus 2x squared plus x minus 5. And then we need to just tack on the remainder, which was a positive 2 over the original divisor. In that black squiggles there is what we're looking for number 9. 10, I believe, is the only one on this side of the paper that we can do synthetic. And why can we? Because this is a 1 and this is a 1. So yay, no long division here, though you could. Let's just set this equal to 0. So x is negative 4. There's our timeout or our box number. And take your coefficients. So 6, 21, negative 14, negative 8, invisible 1, and negative 6. Yay, this one's going to be so much faster. We're going to drop straight down and multiply, and add straight down, multiply, add, multiply, add, multiply, add, multiply, add. And then we just kind of got to work ourselves backwards from that. This last thingy on your right is always the remainder. Constant, x, x squared, x cubed, x to the 4th. So final answer on 10 would be 6x to the 4th minus 3x cubed minus 2x squared. We don't need to put the 0x. Positive 1 with a remainder of negative 10 over the original divisor. Answer. Oh, I love synthetic. That was so much faster than the previous ones. And now it looks like we have just a few more, and we're going to be dividing instead of by a binomial, we're going to be dividing by a trinomial. And you really just do the same thing with long division. It looks horrible, but it's really the same process. I'm coming to 11. Still the divisor on the outside, dividend on the inside. Okay. And again, you're just going to approach it the same way. You want the first part of this to match this. So we need to give it a 5 and 4 more x's. Distribute that through, which would be 5x to the 6th. Distribute here, which would be negative 20, x to the 5th. And here, which would be positive 10, x to the 4th. Subtract the whole shebang. This first one should cancel out. Be careful, this is negative 16 minus negative 20. Off to the side if you need to. That'll turn to plus and be 4x to the 5th. And then again, be careful on the next part. It'll be negative 11, subtract regular 10, which would be negative 21, x to the 4th, and drop down. And then we just repeat the process. Okay, we want x squared to look like the new first component. So he needs a 4 and then 3 more x's to get him up to 5. Distribute, which would be 4x to the 5th. Distribute, which would be negative 16, x to the 4th. And then 8x3. And subtract all the way. First guy should always cancel. We're going to be very careful. That's negative 21 minus negative 16. That turns to addition to give us negative 5x to the 4th. And then that's 22 subtract 8, which is 14. X cubed. And drop down. Okay, and repeat. Again, these are long, annoying, but once you get the hang of it, you just repeat the same process over and over. So we want x squared to look like our new first thing. He needs a -5 and 2 more x's to get him to be -5 x to the fourth. Negative times negative would be positive 20 x cubed. And then that would be -10 x squared. Subtract. Minus minus will be plus and then cancel. 14 minus 20 is -6 x cubed. 14 minus minus, so that would turn to plus and be 24 x squared. And drop down. All right, almost there. We need x squared to look like our new first guy, so he needs a -6 and 1 more x. I'm going to have to scoot to the side to get this on here. So let me just write this. Okay, there we go. Now I'm distributing to be -6x cubed. Negative times negative would be positive 24x squared. And that would be -12x. Gonna subtract. Minus minus will turn to plus and cancel. 24 minus 24, he'll be gone. -4 minus -12 will turn to plus and be 8x. And then we have this 9 to drop down. And that's actually our remainder because we cannot make x squared look like 8x. So this whole binomial here, this is our remainder. So that is a positive 8x plus 9 over the original divisor. Woo! Okay, that at the top is your entire answer. I will highlight it in a yellow box here. You have your quotient and your remainder on number 11. Okay, just a couple more. Number 12. This again will be long division. Right? First to first, he needs a 3 and 2 more x's because that will make 3x to the fourth, 12x cubed, -6x squared, and we'll subtract. First thing should always cancel. 15 minus 12 is 3. 3 minus minus, that would turn to plus and be 9, and drop. Let me bring back my white box here. Okay, repeating the process. We need x squared to look like our new first component, so he'll need a 3 and 1 more x. That'll get him to be 3x cubed, 12x squared, minus 6x, subtract, first guy is gone. 9 minus 12 is -3x squared. -12 minus minus, so that's what turned to plus. -12 plus 6 is -6x, and drop. One more time, I think we'll do it because we're turning x squared into -3x squared. So he just needs a -3. And distributing that through. Subtracting. Minus minus will turn to plus and cancel. Minus minus will turn to plus. -6 plus 12 is 6x. And then 4 subtract 6 is -2. And this binomial is your remainder. So final answer here was 3x squared plus 3x minus 3 with a remainder of 6x minus 2 all over the original divisor. That was 12. Two more. Okay, looking at 13. Oh, gosh. That looks awful because it's to the 6th power, but we got this. Okay. All right, 4x cubed to be 4x6. He's missing 3 x's. That would make him 4x to the 6th minus 3x to the 5th minus 1x to the 4th. If you don't need the 1, feel free to leave that out. Subtract straight down. First thing is gone. -3 minus -3. So that's a plus. So that's -3 plus 3. So he's gone as well. 15 minus minus. So that's a plus. And that'll be 16. Drop down. And then we're probably going to have to drop down that guy as well so that everybody has a partner to line up with. You'll see what I mean once we do the next step. Okay, just repeat the process. We need this 4x cubed to look like our new first guy. 4 times 4 would give us 16, and he's missing 1x because that would get him to 16x to the 4th minus 12x cubed minus 4x squared. Subtracting, he's gone. Minus minus turns to plus. So -12 plus 12, he's gone. Minus minus turns to plus. -4 plus 4, he's gone. So the only thing we have left is to drop down that constant, and that's our remainder. So that wasn't near as bad as it looked. Here's our quotient, here's our remainder. So final answer would be x cubed plus 4x with a remainder of positive 10 over the original divisor. So some of these look just horrific, but once you get into it, that was actually surprisingly not too bad. And we've got one more. Long division one more time. Oh, watch out. There is no x cubed. See how it goes from 4 to 2? We do need to put in the 0. Okay, now we're ready. First to first, he's missing 2 x's. That will make him x to the 4th, 4x cubed, and -1x squared. Subtract. First thing's gone. 0 minus 4 is -4. -17 minus minus, so that's a plus. -17 plus 1 is -16. And drop. So see why we needed that 0 there? Otherwise, we'd be in trouble. There would be nothing to line up with that 4x cube. So remember to put in those, I call them ghost zeros. And now let's go again. X squared needs to look like this. So he needs a -4 and one more x. That will get him to -4x cubed, -16x squared, positive 4x, subtract, minus minus will turn to plus and cancel. Minus minus will turn to plus, and that one's actually going to cancel. And 4 minus 4, that one's going to cancel. So that whole thing is gone, and we're just going to drop the constant. This is our remainder. So again, deceptively easy on this one. Final answer is x squared minus 4x with a remainder of -2 over the original divisor. That's all you can do there. All right, well, I certainly hope this was helpful on this Kuta Software Pre-Calculus dividing polynomials. Thank you and have a good day.